The most powerful survival tool of World War II was not a weapon, but a machine quietly working in kitchens and barns. The public memory of the Second World War tends to focus on weapons, battles, and industrial mobilization. Yet far from the front lines, another struggle determined whether millions of civilians could endure the war years. It was not fought with rifles or artillery, but with tools designed for self-sufficiency. Across Europe, North America, and parts of Asia, entire food systems were pushed to the breaking point during the 1930s and 1940s. Shipping lanes were cut by submarines. Rail networks were redirected almost entirely toward military logistics. Petroleum shortages disrupted transportation and food processing. Electrical infrastructure, especially in war zones, was unreliable or destroyed outright. Under those conditions, a quiet but essential technology became central to survival: the hand-cranked grain mill. It was a simple machine, small enough to sit on a kitchen counter or clamp to a wooden table. Yet this device performed a function that industrial civilization had quietly outsourced to factories long before the war began. It transformed stored whole grains into usable food. Without it, the calories sitting in sacks of wheat, corn, barley, and rye remained locked away in a form that could not easily be eaten. For many households, especially those living beyond the reach of stable supply chains, the grain mill became the beating heart of wartime food security. Understanding why requires looking at the moment when global systems began to fail. Wartime disruptions forced entire populations to rediscover older methods of food independence. By the early 20th century, most industrialized societies had grown accustomed to centralized food processing. Flour mills, bakeries, rail transport, and grocery distribution networks delivered finished products to consumers who rarely thought about how raw food materials became meals. The war interrupted that system with remarkable speed. Merchant shipping losses mounted in the Atlantic. Factories shifted production toward military contracts. Fertilizer supplies were redirected to strategic crops, and civilian food processing often fell behind demand. Even in countries that avoided direct battlefield destruction, transportation capacity was increasingly consumed by the needs of the armed forces. Governments introduced rationing systems to manage scarcity. Coupons regulated access to flour, sugar, meat, and cooking fats. These programs were necessary to prevent hoarding and ensure basic fairness, but they also revealed how dependent civilian populations had become on fragile logistical networks. In rural communities, one fact remained clear: grain itself was rarely the primary shortage. Farmers still harvested wheat, oats, corn, and rye. Grain could be stored in barns, silos, or sacks for months or even years without spoiling. The problem was not the availability of raw calories. The problem was processing. Turning those grains into flour traditionally required mills powered by water, steam, or electricity. When those systems became unreliable, families faced a new challenge. The food was technically present, but it could not easily be prepared. This created what historians sometimes describe as the problem of locked calories. Whole grains contain enormous energy, but without processing, much of that nutrition remains inaccessible. Whole grains are, honestly, among the most efficient food storage systems ever developed. A sack of wheat contains dense carbohydrates, protein, and essential micronutrients. When properly stored, it can remain edible for years. But whole grains are not easily consumed in their raw state. The outer bran layer is tough. The interior starches require grinding or cracking to become digestible. Historically, communities solved this problem through communal milling systems powered by rivers or wind. By the 1930s, however, many households had lost the habit and the equipment needed to process grain themselves. The war forced a return to these older technologies. Families who still owned hand-cranked grain mills suddenly possessed a critical advantage. They could convert stored grain into flour regardless of electricity, fuel availability, or factory production. Even small amounts of grain could be processed daily, allowing households to maintain a steady supply of bread, porridge, or coarse meal. In practical terms, the grain mill transformed raw agricultural storage into daily sustenance. That transformation was simple in principle, but it depended on a remarkably well-designed tool. The hand-cranked grain mill was a piece of engineering built for independence. The basic design of the hand grain mill had existed for centuries, but by the early 20th century, manufacturers had refined it into a compact, efficient household machine. Most models used two grinding surfaces, often made of hardened steel or cast iron burrs. One surface remained fixed while the other rotated when the handle was turned. Grain dropped between the burrs, where the kernels were crushed and sheared into smaller particles. By adjusting the spacing between the burrs, the user could produce anything from coarse, cracked grain to relatively fine flour. The mechanism required no external power source. Human muscle alone provided the energy needed to operate it. In peacetime, this might have seemed a bit inconvenient compared with electric mills, but during wartime shortages, it became an extraordinary advantage. A family could grind enough flour for bread in just a matter of minutes. Larger batches could be prepared for community baking or extended households, and because the machine was mechanical rather than electrical, it stayed functional even during prolonged blackouts. Durability was another key feature. Wartime craftsmanship, well, it really emphasized longevity over convenience. Manufacturers of pre-war grain mills often built them with materials intended to last decades. Thick cast iron housings resisted wear, and steel burrs maintained their cutting surfaces through years of use. Simple threaded adjustments allowed users to recalibrate the grind as components slowly wore down. These machines were not disposable appliances. They were tools designed to remain part of a household for generations. That design philosophy proved essential during wartime conditions, when replacement parts were difficult or impossible to obtain. Families relied on equipment that could endure constant daily use without complex maintenance. In many cases, the mill survived not only the war itself, but also the decades that followed. Some remained in operation long after modern electric appliances became common again. Their usefulness also extended far beyond wheat flour. The versatility of the grain mill allowed households to adapt to whatever food sources remained available. Although wheat bread occupies a central place in many wartime narratives, families rarely had the luxury of relying on a single grain. Agricultural conditions, rationing rules, and local availability forced constant adaptation. A good hand mill could process far more than wheat. Corn could be cracked for porridge or ground into meal for flatbreads. Barley could be milled for soups and stews. Rye could become dense, nutritious loaves that stored well for days. Even legumes such as dried peas or beans could sometimes be crushed into coarse flour for thickening soups. This flexibility mattered enormously when official ration allocations changed from month to month. Households that possessed both stored grains and a reliable mill could improvise meals from whatever supplies were available. Those without such tools often depended entirely on commercial flour distributions, which, honestly, were not always consistent. But the grain mill was only one piece of a broader survival system. Food resilience depended on three linked steps: storage, processing, and cooking. Historians studying wartime civilian life often emphasize that survival rarely depends on a single tool. Instead, resilience emerges from systems. In the case of household grain consumption, three elements had to function together. First, families needed long-term storage for raw grains. Properly dried and protected from pests, these stores represented months of potential calories. Second, they needed a way to process the grain. The hand-cranked mill filled this role by converting stored kernels into usable flour or meal. Finally, they needed cooking methods that worked even when fuel was limited. Wood stoves, coal ranges, and simple ovens allowed families to bake bread or prepare grain-based dishes without relying on modern infrastructure. When these elements operated together, households achieved a surprising level of independence from disrupted supply chains. This independence also influenced how people evaluated the quality of their equipment. Families learned to judge grain mills by reliability rather than convenience. During the war years, households quickly discovered that not all mills were built to the same standard. A reliable mill needed strong burrs that could grind hard kernels without chipping. The adjustment mechanism had to hold its position so that flour texture remained consistent. The handle required enough leverage to make grinding manageable even for older family members. Poorly constructed mills often revealed their weaknesses quickly. Burrs dulled or cracked. Frames warped under pressure. Adjustment screws slipped during operation. Experienced users developed informal tests for evaluating quality. They checked how smoothly the handle rotated under load, whether the burrs maintained alignment, and whether the mill produced consistent flour without excessive effort. Such practical knowledge circulated through families and rural communities, shaping purchasing decisions whenever new equipment became available. Maintaining these machines also required care. Proper maintenance protected the cutting surfaces that made the mill effective. The heart of a grain mill lies in its burr geometry. The cutting surfaces must remain sharp and properly aligned to crush kernels efficiently. Over time, abrasive grain particles gradually wear down those surfaces. Wartime households addressed this problem through careful cleaning and occasional reconditioning. Users brushed away accumulated flour dust, which could attract moisture or insects. If burrs became too smooth, they could sometimes be lightly resurfaced to restore their grinding texture. Lubrication of moving parts ensured that friction remained manageable during long grinding sessions. These maintenance habits were not complicated, but they reflected a deeper understanding of mechanical systems. When replacement tools were unavailable, preserving the functionality of existing equipment became essential. That effort paid off in the form of better nutrition. Freshly milled grain protected families from hidden forms of malnutrition. Industrial flour production often removes portions of the grain kernel, especially the bran and germ. These components contain many of the vitamins and minerals necessary for long-term health. When households milled their own flour from whole grains, those nutrients remained intact. This really mattered greatly during wartime rationing. Diets narrowed as access to diverse foods declined. Freshly milled grain provided fiber, B vitamins, and other micronutrients that helped prevent deficiency diseases. Bread baked from whole grain flour was heavier and darker than commercial white loaves, but it was, honestly, nutritionally superior. For families facing months of limited food variety, that difference could influence overall health and resilience. In this sense, the grain mill was not merely a tool for producing flour. It was a safeguard against the slow erosion of nutritional quality during prolonged scarcity. It also offers a revealing comparison with modern technology. The grain mill demonstrates the power of resilient engineering in an age of fragile systems. Modern kitchens contain appliances capable of extraordinary convenience. Electric grinders, food processors, and automated bread machines can all produce results quickly and with minimal effort. But here's the thing, these devices share a common vulnerability. They depend entirely on complex supply chains and reliable electricity. The hand-cranked grain mill, well, it actually represents a different philosophy of engineering. Its design assumes that infrastructure may fail. It prioritizes mechanical simplicity, repairability, and independence from external power sources. During the Second World War, that philosophy, believe it or not, proved invaluable. Households equipped with such tools, honestly, retained the ability to feed themselves even when industrial systems faltered. Their survival did not depend solely on distant factories or vulnerable transportation networks. Instead, it rested on knowledge, stored resources, and machines simple enough to function under almost any conditions. Those lessons, I think, remain relevant today. Studying these tools really reveals how resilience grows from mastering simple systems. Historical analysis often emphasizes grand strategy and battlefield outcomes, but the survival of civilian populations depended just as much on small, practical technologies. The hand-cranked grain mill, for example, illustrates how preparedness operates at the household level. It converts durable food storage into daily nourishment. It needs no electricity, no fuel deliveries, and honestly, no specialized infrastructure at all. More importantly, it reminds us that resilience is rarely accidental. It emerges from deliberate choices about how systems are designed and maintained. Families who kept these tools understood something fundamental. Independence begins with the ability to transform raw resources into usable necessities. That insight shaped daily life throughout the war years and continues to influence modern discussions about preparedness. Remembering these overlooked wartime technologies offers a blueprint for future resilience. The story of the humble grain mill rarely appears in popular histories of World War II. It lacks the drama of battlefield narratives or the scale of industrial mobilization. Yet for countless families, it was one of the most important machines in the house. It turned sacks of stored grain into bread on the table. It preserved nutrition during years of scarcity. And it allowed ordinary people to maintain a measure of control over their survival when larger systems broke down. Understanding these quieter technologies deepens our picture of how societies endure crisis. If you value exploring the overlooked tools, decisions, and innovations that shaped history, consider subscribing to Hidden in History and sharing this video with others who appreciate in-depth historical analysis. Stories like this remind us that resilience often begins in the smallest and most practical places.